We're doing ASFurther pure maths, and we're in unit 4 vectors, and we're looking then at the distance of a point from a plane. It's 4.16, so let's talk through the theory, and then to be honest, we'll just give you a quicker way of doing it, but let's go through this anyway as if things are normal. The diagram shows a plane which contains the point A, there's the point A, with position vector A, and also contains any other point R with position vector A. The unit vector N, that's it going straight up there, obviously it's perpendicular to the plane. The line OA makes an angle theta, so where's that? There's OA and there's your theta, and D is the distance of 0 from the plane. So D equals A cos theta, because there's your right angle triangle there. Obviously there's your A, which is the hypotenuse, D is the adjacent, and so cos is D over A, and so D then equals A cos theta. Also equals then A dot 1 dot cos theta, so that's okay, which then is A n cos theta, since n is the unit vector, and so t equals a dot n, where n then is unit vector. Now an equation of the plane is r dot n equals a dot n. Thus, if you replace the vector a by n in the scalar product formula, the equation of the plane, you get r dot n equals d, where d is the perpendicular distance from the origin to the plane. If you have 3 parallel planes, 1, 2, 3, and if n is a vector perpendicular to one of these planes, then n will be perpendicular to each of these planes. Suppose the equations of the planes are r dot n equals u, r dot n equals v, r dot n equals minus w, obviously going that direction then. Then if you rewrite the equations, r dot n equals a, r dot n equals b, r dot n equals c, where a is u over n, b is v over n, c is w over n, then a, b and c are the perpendicular distances from O to each of the planes. The significance of the minus sign is that it indicates that the third plane is in the opposite side or the other way then from the origin, and so that's how you can work out the distance. You're not going to do that because in the formula booklet you have a wee formula, just works it out. So let's take that down. So, or use formula in booklet, and if you have a point in alpha, beta, gamma, sorry my gamma should be straighter up here, my alpha should be straighter down, it's from the equation n1x plus n2y plus n3z plus d equals 0. So there is your plane. So the distance then point to plane is equal to the modulus of n1 alpha plus n2 beta plus n3 gamma plus d all over the square root of n1 squared plus n2 squared plus n3 squared, sorry, that's the wrong way around, the squared's there, that's the 3 there, and we end up with that. So use that formula there from this point here, and this is the equation of the plane, that's going to tell you then the distance. So let's try that for a couple of examples and we will see how we go. Find the perpendicular distance from the origin to the plane 2I plus 4j minus 3k equals 7. So we are going to rewrite the equation in the form we need. So we'll rewrite equation as 2x plus 4y minus 3z, and remember then we got to write it in this form here. See the plus and d, so we need to take the number over, minus 7 equals 0. Then perpendicular distance is your big formula. It's obviously n1 alpha plus n2 beta. Now remember alpha, beta and gamma, it's the origin, so that's 0 and that's 0 and that's 0, and that then is just going to be minus 7. So this is going to be 0 plus 0 plus 0 minus 7 all over the square root then of 2 squared plus 4 squared plus 3 squared. We're taking the modulus of that, so the minus 7 becomes a positive, so 7 over root 29 then is our answer to that, and that's us done. Example 2, it's not from the origin, so let's take a wee look at that and see if we can suss that one out as well. So our point is 316, so let's rewrite this then as 2x minus y minus 2z minus 13 equals 0. So that was us rewriting an equation. And then it's the point 316. So our distance then that we require, that's our big formula if you remember, it's going to be 2 times 3, so 2 upon 3 plus 1 upon minus 1 plus 6 upon minus 2 minus 13 all over the square root of 2 squared plus minus 1 squared plus minus 2 squared. So what are we going to have? We're going to have 6 minus 1 minus 12 minus 13. That's what we have there on the top. On the bottom, 4 plus 1 plus 4, so that's 9. The square root of 9 then is going to be 3. We'll just write square root of 9 and tidy it up in the next line. 6 take away 1 is 5, take away 12, take away 13. Sorry, I lose my mind here, right? 1 plus 12 plus 13 is 26, so that's minus 26 plus 6, so we just end up then with 20 over 3, and our answer then is 6 1/3. It's not, it's 6 2/3, so close.